important thing when we compare it with the other number system is the inclusion of 0 in our system, 0. Now, any idea how that 0 came in India, but the others did not get it? Because we had a different number system existing in all over the world, like we showed it in Egyptian, we had Mesopotamian, they have Greek, they have Romans, they have, but they never had 0 with them. Why only we had that opportunity to get 0? But now, I have certain books here. Now you said Aryabhatta, that's why I just looked for the books. In whatever I have read, Aryabhatta was the first author who had written a mathematics book with his name on it. That author's name was already given. That was happened in AD 499. But 0 is a symbol which was used even before Christ. 0 means that shape, O shape. That symbol was used for 0 even before Christ. So I'm not sure about that it is Aryabhatta, but he might be the one first who used in his book and where his name was already written as the author. But the reason for coming, even Aryabhatta, if he takes 0, why Aryabhatta took 0, or how did he get 0? Yeah, the important thing is, in our language, Sanskrit, we have a word called shunya. Now, shunya, exactly from that word, the 0 part was derived. We used to call it as shunya. 0 came from England. Now, I just like to draw the attention, the history of this part. We used to have trade with the European countries, but this trade was through the Arab countries. So we need to go through the Arabs for doing any business with the European countries. And we had a very nice decimal system to represent the things. But as far as the Arabs are concerned, seeing the simplicity of these numbers, they started to study our number system. The Caliph of Persia, it was in the the business was going very well. So the Caliph of Persia, Al-Mansur, his name was Al-Mansur, he sent his mathematics scientists to India to study about our number system, and so that they can also use in their country as far as this business is concerned. And he came here, his name was Al-Khwarizmi, his name is written. He came here, he did a very good job. Now he translated all the numbers into that Arabic name. But the problem was in empty, the shunya, when we represent it, the word is empty. In Arabic, we don't have a word for empty. Instead, they have a word for void, V-O-I-D. Again, that is similar meaning. So he converted this empty, instead of empty, in Arabic he took the word, as you see, as sifr, as A-S-S-I-F-R, as sifr. Now usually after using it for many years, it became just sifr. Now, the Latin word for cipher is sephirum. I have written the second line, and it was used by Leonardo Fibonacci. You might be aware of the Fibonacci series and all. It was used by Leonardo Fibonacci, that word sephirum, in Latin, because he used to write in Latin. So in Latin he used sephirum instead of cipher, because cipher was the Arabic word, so he converted into Latin, so it became cipher. Now usually when you use a thing, slowly changes happens. So cipher became zero, then it became sepiro, cifra, cipher, seron. Now it went to England in the name of Seron, Z-E-R-O-N, that is crossing the channel. It went to England as Seron. But in England it became 0. Now that 0 now we use as our, we use that 0. So actually this 0 originated from the translation of empty in Arabic, that conversion, that came back as 0. So one way we can proud of it, because we are the one who gave the world the very best number system that is existing. If you remember, in 17th, 18th and 19th century, there were many discoveries regarding chemistry, physics, but all those subjects, what happens is that they represent the things by an equation. Maybe it might be a differential equation, it might be an algebraic equation, but again, these equations, we need to substitute the values to do the calculation. Now, to do the calculation, this was the number system that was the best available. So we can all be proud in that way. Now, even people say certain times, it's just for the joke purpose, they say the contribution of Indians to the mathematics, 0. They say it is 0. But the important 0 is very different. It is very, very important. Now, there is a nice part of it. If you start playing table tennis or tennis or even volleyball for that purpose, what is the score? Love all. What it means? Love all. Actually, it starts with the tennis game in France. So in tennis, you see that word, love, U-L. That word means egg. In French, it means egg. Now, what is the shape of the egg? 0. That O shape. So that's why they started saying that love all, and it became love all. So nowadays, for any game, you can see that we use that part, love all. But it means actually it started from that 0 business. Now in cricket, you might be, duck is quite familiar to those who watch cricket. It started in England. Instead of using love all, what they changed a bit, then they said duck's egg. Duck's egg. Now usually you start using it, the egg part went away and it became only duck. So instead of 0, again they use that duck. Okay. So that was about 0. Now one particular set of numbers, which we call it as prime numbers. What are primes? Anyone? What? 2 factors. It has got 2 factors. It cannot have more than 2 factors. It can have 2 factors. One is 1 itself and the number itself. Now, which is the least prime number? 2. Which is the largest? We don't know. We don't know. The least one is 2. Okay, that is prime number. So if they are not prime number, we can call them as composite numbers. Now there are many interesting properties as far as prime numbers are concerned. One, as you said, we don't know which is the last one. There are certain prime numbers. They are of the form p plus 2, which we call it as twin prime numbers. For example, 3 and 5. The difference between those prime numbers is 2. So we call them as twin prime numbers, 3 and 5. 5 and 7. All prime numbers are twin prime numbers? Give me one example. 23. Because you take 21 and 23. 21 is not a prime. And similarly, you take 23 and 25. They are not prime. But there are infinitely many twin prime numbers, and nobody have given any proof for that. So what one can do is, you can always strive for this. After next 2 slides, you can see that there is an institute, Clay Mathematical Institute. In short, we call it as CMI, Clay Mathematical Institute. To encourage the students to do mathematics, in their website, they have given 7 problems, unsolved problems. I'll just show you those problems. 7 unsolved problems, and what they say is, if you solve any of those problems, any of those 7 unsolved problems, if you solve it, they will give you $1 million. And they are known as $1 million problem. In a way, you are little unlucky because out of those 7, 1 is already solved. And he already received $1 million. One Perelman, he had solved one of those 7 problems. Anyway, we'll come to that. So we have prime numbers, that is integer which is greater than 1 and can be divided by itself and 1. So we have 2 factors, one is itself and the other one is 1. Other numbers we call it as the composite numbers. Now important theorem in prime numbers is fundamental theorem, which we call it as fundamental theorem of arithmetic, which says you give any integer greater than 1, it can be factored into primes in one and only one way. That is always a unique way. Maybe the factors you can rearrange in different way. Like the one written 12, it can be 2 into 2 into 3 or 3 into 2 into 2. But this can be done only one way. There are no other primes available using which you can represent the given particular number. This theorem is known as the fundamental theorem of arithmetic. Now the twin primes we are talking about. All prime numbers are not twin primes, but there are infinitely many twin primes, and this is something you can try to prove it as far as prime numbers are concerned. This is another conjecture. The proof is not given. Nobody has given any proof, but you take any number and try to verify that this is true, that whatever he says is correct. But no general proof is given to it so far. Now what that conjecture says is that every even number greater than or equal to 4 is the sum of 2 primes. Now that means for certain numbers that is not correct. Which numbers? Every even number greater than or equal to 4 is the sum of 2 primes. Okay, for 2, because it is less than 4. But it is for every even. Odd, there are odd numbers. You say for which this theorem is not true. But for even numbers, this is true. Again, this is not proved. So if somebody is interested, you can always try for that. Now, there was a time when people used to celebrate the discovery of prime numbers. Now, as you see, this is a stamp of US in 1968, when one prime number was found, the largest. At that time, it was the largest one. That is 2 raised to 11,230 minus 1 is a prime. He had found out that number as a prime. And the government, in the name of that, released a stamp just to remember that. Now, have you heard of cryptography? Yes. Yeah. What we do in that? In cryptography. Yeah.
They actually convert a simple statement into a coded statement.
Yeah, coded statement, so that others will find it difficult unless you know to decode it. Right. Now, for that purpose, the prime numbers are a very good tool to create the code. Prime numbers. As I said, 21 is a number which is the product of 2 prime numbers. They are 3 and 7. Now, 21 is a very small number, so it is easy to say 3 and 7. We can easily find out. But if